Hello everyone, welcome. So in this video, we're going to see linear algebra 2023 solution, right? Already we have completed 2024 solution of linear algebra. 2024 has 5 questions for overall mark of 70 marks. Same year also. So 2023 has again 5 questions, overall 70 marks from linear algebra. So as I said in the previous class itself, in the previous video itself, that linear algebra easily you can get 70 marks if you know the basic ideas of all the concepts, right? Yes. So we will start our first problem. So we'll start 2023 linear algebra solution, right? Okay. Again, it has 5 questions. So we'll start with the first question. Let v1 is equal to 2 minus 1 3 2, v2 is equal to minus 1 1 1 minus 3, v3 is equal to 1 1 9 minus 5. The three vectors of R4. Thus, this 3 minus 1 0 minus 1 is in the span of these three vectors. Justify your answer. That is what they are asking, right? Okay. So solution. So we have v1, v2, v3. V3 vectors of R4. So we have three vectors v1, v2, v3, and three vectors belongs to R4, right? These three vectors belongs to R4. Now we need to say whether this vector 3 comma minus 1 comma 0 comma minus 1 belongs to span of v1, v2, v3, right? So if this vector can be written as a linear combination of these vectors, then we can say this vector is in span of v1, v2, v3, right? That is, this will be this this will be in span if this vector 3 comma minus 1 comma 0 comma minus 1 can be written as a linear combination of these vectors v1, v2, v3. That is, if there exists if there exists x1, x2, x3, then I can say that this vector can be written as a will be in the span of v1, v2, v3, right? Okay, that is, if this x1, x2, x3 are scalars, right? That belongs to real number because we are in R4, R4 of R here. Our vector space is R4 of R. Okay. So x1 times v1. So what is v1? So v1 is 2 minus 1, 3, 2 plus x2 times what is v2 minus 1, 1, 1 minus 3 plus x3 times v2 is 1 comma 1 comma 9 comma minus 5. So if there exists some x1, x2, x3, then I can say that this will be in the span. Now you just have to find whether is there any x1, x2, x3 that makes this linear combination as 3 minus 1, 0 minus 1. So this reduces to an homogeneous system of linear equations, right? Homogeneous system of linear equations. So what is the equation we have here? So we have 2x1 minus x2, 2x1 minus x2 plus x3 is equal to 3. And here we have minus x1 plus x2 plus x2 plus x3 is equal to minus 1. 3x1 3x1 plus x2 3x1 plus x2 plus 9x3 is equal to 0. And then we have 2x1 minus 3x2 2x1 minus 3x2 minus 5 times x3 is equal to minus 1. This is what we have here, right? If you multiply and equate. So, which is a homogeneous system of equations, right? Which is a homogeneous system. Sorry, which is a non-homogeneous system, right? Because output vector is non-zero vector, which is a non-homogeneous system. So we will solve this non-homogeneous system to find the solution of x1, x2, x3. If there exists a unique solution also, no problem. We can find x1, x2, x3 that makes this linear combination of 3 minus 1, 0 minus 1. If there exists infinitely many solution also, no problem. Then also there are many x1, x2, x3 that makes this linear combination as this. Right. So for this homogeneous, non-homogeneous system, even if it has unique solution, this vector will be in the span. Even if this has infinitely many solution, this vector will be in the span. If this system has no solution, then this vector will not be in the span. Yes or no? If this system has unique solution, this is a non-homogeneous system. Three cases: unique, infinite, no solution. If this system has unique solution, then there is one x1, x2, x3 that makes this linear combination as 3 minus 1, 0 minus 1. That means this will be in the span of v1, v2, v3. Even if the system has infinitely many solution, then there are many x1, x2, x3 that makes this linear combination as this. Again, this will be in the span of v1, v2, v3. But if this system has no solution, then there is no x1, x2, x3 that makes this linear combination this. That means this will not be in the span. That is the idea we are going to do now. Now we will solve the system of equations. So we will try to reduce this to row echelon form. So we will find the augmented matrix A comma B. So we will find the augmented matrix A comma B. It is a homogeneous system AX equal to B, right? Why I am telling homogeneous? It is a non-homogeneous system AX equal to B. Okay. Non-homogeneous means the output vector is a non-zero vector. If the output vector is zero vector, then it's a homogeneous system. Okay. So we'll solve this non-homogeneous system. So the augmented matrix is 2 minus 1, 1, 3. 2 minus 1, 1, 3. 2 minus 1, 1, 3. Minus 1, minus 1, 1, 1, minus 1. Minus 1, 1, 1, minus 1. And then we have 3, 1, 9, 0. 3, 1, 9, 0. And then here we have 2 minus 3 minus 5. 2 minus 3 minus 5, 1. Right. So we'll reduce this to row echelon form. Right. We'll reduce this to row echelon form. So I'll just make some adjustment. I'll multiply this by minus throughout and then I'll switch this. So 1 minus 1, 1 minus 1 minus 1, 1. 2 minus 1, 1, 3. 3, 1, 9, 0. 2 minus 3 minus 5, 1. Right. That is I have interchanged R1 and I have multiplied by minus R2. Right. Okay. So we'll make this as row echelon form. So we have R2 is transformed to R2 minus 2R1. R3 is transformed to R3 minus 3R1. R4 is transformed to R4 minus 2R1. It is not mandatory that this element has to be 1, but if it is 1, then our calculation will be easy when compared to the previous, when compared to that, right? That's why you're doing this. So this reduces to 1 minus 1 minus 1, 1. So this will be 0. So minus 1 plus 2. Minus 1 plus 2 is 1. 1 plus 2 is 3. And here we have 3 minus 2 is plus 1. R3 minus 3 times R1. So 1 plus 3. 1 plus 3 is 4. 9 plus 3 is 12. 9 plus 3 is 12. 0 minus 3. Right? 0 minus 3. And then R4 minus 2 R1. So minus 3 plus 2. Minus 3 plus 2. Minus 5 plus 2. Minus 5 plus 2. Minus 1 minus 2. This minus 1 minus 2, right? So what we are doing here, we are multiplying this by 2 and then we are subtracting. Minus 1 minus 2 minus 3. Yes. Now what we will do is we will make this element as 0, this element as 0. So we will have 1 minus 1, 1. 0, 1, 3, 1. So let us multiply So R3 is transformed to R3 minus 4 times R2, and then R4 is transformed to R4 plus R2, right? R4 plus R2. So you multiply 3, sorry, you multiply 4 and then you subtract. What do you will have? Um, what do you will have? You multiply 4 and then you subtract. You multiply 4 and then you subtract. You multiply 4, so minus 3 minus 4. This will be minus 7, I think. R4 plus R2. So 0 plus 0, minus 1 plus 0, minus 3 plus 3, minus 3 plus 1, which is minus 2, right? Now we will make this element as 0 because first row, first non-zero element, below that everything is 0. Second row, first non-zero element is 1, below that everything is 0. Third row, first non-zero element is minus 7, below that it is not 0. So we will make R4 as 7 times R4 minus R3. So this reduces to 1 minus 1 minus 1 1 0 1 0 1 3 1 0 0 0 minus 7 0 0 0 0, right? Yes. Now this is in row echelon form, right? What about the rank of A? Rank of A is 2, right? Rank of A is 2. What about rank of A comma B? It is 3, right? Rank of A comma B is 3. So this is our A, this is our A, and fully it is A comma B, augmented matrix. So I've already explained how to solve a homogeneous and non-homogeneous system in the live lectures. You just go to the live section. You can watch all the videos of how to find the solutions for homogeneous and non-homogeneous, right? Okay. Now that means here you see rank of A is not equal to rank of A comma B. That means it has no solution, right? It has no solution. That means there is no x1, x2, x3. So that means this vector will not be in the span. So that means minus 3, 1, minus 3, minus 1, minus 1, 0, minus 1 will not belongs to span of v1, v2, v3 because there is no x. See, even if it has infinitely many solution also it will be in the span. Even if it has unique solution also it will be in the span. It is plus 3. So that means there is no x1, x2, x3. So that means this will not be in the span. See, 10 marks, very simple question. It turns out to be solving the non-homogeneous system of linear equations. That's it. So we'll move on to the next problem. Is the problem is clear? Okay. Find the rank and nullity of the linear transformation. Again, very simple. In 2024 video itself, I have explained you very deeply about what is meant by range space. Dimension of range space is your rank, and dimension of null space is your nullity. Right? Here you don't need to find basis at all. You just have to find the dimension of null space and dimension of range space. That's it. Okay. So first, what we will do is we will find the corresponding matrix for this linear operator, and for that corresponding matrix, we will find the uh, rank and nullity. Okay. So we will find the corresponding matrix. So with respect to the standard basis, so 1 comma 0 comma 0. So let the standard basis be 1 comma 0 comma 0, 0 comma 1 comma 0, 0 comma 0 comma 1. Right? We will try to find the matrix for this t with respect to the standard basis. So t of 1 comma 0 comma 0, it will be what? 1 plus 0, 1 plus 0 plus 0, 2 plus 0 plus 0. So which is 1 comma 1 comma 2. Now you have to express this 1 comma 1 comma 2 as a linear combination of the basis vector. So which is x1 times 1 comma 0 comma 0 plus x2 times 0 comma 1 comma 0 plus x3 times 0 comma 0 comma 1. So x1, x2, x3 turns out to be 1, 1, 2, right? Because if you multiply, you will have x1, x2, x3. You will have x1, x2, x3. Now t of 0, 1, 0. What is t of 1, 0, 0? It is 0, 1, 0. Sorry, 0, 1, 1. Now we have to express 0, 1, 1 as a linear combination of the vectors, basis vectors. So let us say x4 times 1, 0, 0 plus x5 times 0, 1, 0 plus x6 times 0, 0, 1. So it turns out to be x4, x5, x6, and next vector is basis vector is 0, 0, 1. So x is 0, y is 0, z is 1. So 1, 2, 3. So let us say some x7 times 1, 0, 0 plus x8 times 0, 1, 0 plus x9 times 0, 0, 1. So I strongly recommend you to watch 2024 solution and then 2023 solutions, because in 2024 I have explained very deeply about this. So this turns out to be some x7, x8, x9. So the matrix of T with respect to the basis is given by the unknowns which you need to find x1, x2, x3, x4, x5, x6, x7, x8, x9. So these are the unknowns which you need to find. But if it is a standard basis, that unknowns finding is very easy, because your x1, x2, x3 is nothing but 1, 1, 2. Is nothing but 1, 1, 2, and x4, x5, x6 is nothing but 0, 1, 1. We are just equating these two, and x7, x8, x9 is nothing but 1, 2, and 3. This is the matrix of T with respect to the standard basis. If it is a standard basis means, then you can write this output vector directly in the column format. If it is not standard basis means you should not write. Actually, what you should write here is you have to write those linear combination numbers. You have to write these numbers here, x1, x2, x3. You have to find x1, x2, x3. That means you have to write this vector as a linear combination of basis vector. Basis vector is standard basis vector is this. If you solve for x1, x2, x3, it turns out to be this, right? Okay. You have to write this x coefficients here, right? Okay, this is the matrix of T with respect to the basis. Now you just find the rank and nullity. Just find the rank for this. So R2 is transformed to R2 minus R1. R3 is transformed to R3 minus 2 times R1. This is equivalent to 1, 0, 1. So 1 minus 1 is 0. 1 minus 0 is 1. 2 minus 1 is 1. You multiply 2 and then you subtract. You multiply 2 and then you subtract. You multiply 2 and then you subtract. Right? Again, this is equivalent to 1, 0, 1, 0, 1, 1, R3 minus R2. So 0, 0, 0. Right? So what is rank? Rank is nothing but total number of non-zero rows. So rank is equal to total number of non-zero rows. This word is important actually. Non-zero rows in reduced echelon form. In reduced echelon form. So that means rank of the corresponding operator is given to be 2. And to find nullity, we know that rank of T plus nullity of T is equal to dimension of domain space. It is a map from R3 to R3. So that means nullity of T is equal to 1, right? Nullity of T is equal to 1 because rank of T is 2. So 3 minus 2 is 1. See here they haven't asked you to find a basis for a null space. They are asking you to find rank and nullity. Both are numbers only, right? So rank nullity of T is 1. Rank of T is 2. It is 10 mark question, right? Suppose if they ask you to find basis, what is the basis for a range space? 1, 0, 1, 0, 1, 1. You write this vector. If you want to find nullity, you just find the solution for Ax equal to 0. discussed in 2024 problems. You just find the solution for Ax equal to 0. That is, you are finding all those vectors that is going to 0 vector of codomain, right? That has one linearly independent vectors. That null space will have one linearly independent vectors. That is why you are having nullity of T to be equal to 1, right? So we'll move on to the next problem. So very simple problem, 10 mark question. Nothing is there, nothing here. Very simple. Okay. Suppose if you want to find null space, let us try to find null space also, right? So these are just practice for us. So we'll do some extra things also. Suppose if you want to find null space, right? This is not at all needed. They are asking only nullity. To find null space, what you have to do? What is null space actually? So null space of T consists of all those vectors in R3 that are mapping to 0. So T of x is equal to 0. So you collect all those x comma y comma z such that T of x is equal to 0. Our x is x comma y comma z, right? So that means so what is our T? Our T is 101, 101, 112, 101, 112, 213, 213. Let us say x comma y comma z. Okay. X comma y comma z is equal to 0, 0, 0, right? Is equal to 0, 0, 0. So you just find the augmented matrix A comma O. Usually A comma B are non-homogeneous. For homogeneous, you write as A comma O. So which is 1, 0, 1, 0, 1, 1, 2, 0, 2, 1, 3, 0. You have to solve this homogeneous system, right? You have to solve this homogeneous system. So reduce to row echelon form. So already we know the reduced to row echelon form, right? Which is 101, which is 1010, and then 0 1 1 0 1 1 0 0 0 0 0. This is a reduced row echelon form, and you can see what is our number of free variable is what. So number of free variable is equal to total variable minus rank. So you have one free variable, and if you try to reduce, if you again convert to ax is equal to 0, so you'll have an equation x plus z is equal to 0, and then we have y plus z is equal to 0, right? X plus 0, y plus z is equal to 0, y plus z is equal to 0. So let us take z to be equal to k. So y is minus z. So that means y is minus k, x is minus z, again it is minus k. So x comma y comma z, the solution space is given by x is minus k, y is minus k, and z is k. That means k times minus 1 comma 1 comma 1. So I can see this is our solution space. That means all these set of vectors will map to 0. For example, you take minus 1, minus 1, 1. Minus 1, minus 1, 1. If you put minus 1, minus 1, 1 here, what will happen? You just see 1 into minus 1, minus 1, 1 into 1. So minus 1 plus 1 is 0. We are putting x to be minus 1. So minus 1, minus 1, minus 2 plus 2, which is equal to 0. That is the idea, right? So that means null space of T consists of k times minus 1 comma minus 1 comma 1, and this k belongs to real number. This null space has infinitely many vectors, but how many linearly independent vectors are there? Only one linearly independent vector. So that means dimension of null space of T is 1 because it has one linearly independent vector. That is what we discussed here also, right? Dimension of null space of T is nothing but nullity of T. So that means all these vectors will map to 0 vector. All these vectors will map to 0 vector, right? If it is not 1 1 also, why? Because infinitely many vectors mapping to this, it is not 1 1. As a result, it is not invertible also, right? Whenever rank is equal to dimension only, it is invertible. Here rank is 2, dimension is 3, it is not invertible, right? Okay, many insights you will get. Okay, so we'll move on to next problem. if the matrix if the matrix of linear transformation T From R3 to R3, relative to the basis 1, comma 0, comma 0, 0, comma 1, comma 0, 0, comma 0, comma 1 is given by this. Then find the matrix of T related to the basis 1, comma 1, comma 1, 0, comma 1, comma 1 and 0, comma 0, comma 1, right? Okay, now we will do this. Okay. Now we will find a linear map first, right? We will find a linear map. Here they have given that T of 1, comma 0, comma 0 takes 1, comma minus 1, comma 0. T of 0, comma 1, comma 0 takes 1, comma 2, comma 1. T of 0, comma 0, comma 1 takes 2, comma 1, comma 3. That is what they are given here. We will find a map T of x, comma y, z. T of x, comma y, comma z. We will find a map T of x, comma y, comma z. So we will find this linear map. Then it is easy to find the matrix of T with respect to this basis, right? Okay. Now we will find a linear map T. We will find a linear map T of x, comma y, comma z in generally. Generally, we will try to find, right? Okay. Now let us take some vector. Let us take let x, comma y, comma z belongs to R3. So that means any vector can be written as a linear combination of basis vector. That means x, comma y, comma z can be written as a times 1, comma 0, comma 0 plus b times 0, comma 1, comma 0 plus c times 0, comma 0, comma 1. Our aim is to find the value of ABC in terms of x. If it is standard basis, it is easy to find the value of ABC in terms of x. If not, we have to find, our aim is to find ABC value in terms of xyz, right? Okay. Now, if it is standard basis, it is easy to find, right? This implies A is equal to x, B is equal to y, C is equal to z. If it is not standard basis, means you just have to equate and then you have to write ABC in terms of x. That we will do. If that kind of problem comes, surely that kind of problem is there in PYQ. We will do this. We will do that at that point of view, right? As of now, whenever you try to remember that if you want to find the corresponding x, comma y, comma z, if the matrix is given, our aim is to write. You take any vector in the domain, you write that vector as a linear combination of given basis vector. Our given basis vector is standard basis 1 0 0 0 1 0 0 0 1 for this matrix. After this, you have to write this ABC in terms of XYZ, right? If it is standard basis, writing ABC in terms of XYZ is easy. Just have to solve these two. So you'll be getting A, comma B, comma C is equal to X, comma Y, comma Z. That means this X, comma Y, comma Z can be written as, so that means this X, comma Y, comma Z can be written as x into 1, comma 0, comma 0, y into 0, comma 1, comma 0 plus z into 0, comma 0, comma 1. With standard basis, it is easy to find ABC in terms of x, y, z. If not, it will take some 1 or 2 minutes to find that, right? Okay. Now you take t on both sides. So t of x, comma y, comma z is given by t is satisfies that scalar property. You can multiply that. You can take t out x outside because x, y, z are numbers only, right? So t of 1, comma 0, comma 0, y times t of 0, comma 1, comma 0 plus z times t of 0, comma 0, comma 1. So x times, what is t of 1 0 0? We know, right? It is 1 minus 1 0 plus y times, what is t of 0 1 0? It is 1, comma 2, comma 1 plus z times, what is t of 0, comma 0, comma 1? It is 2, comma 1, comma 3. What's our first step? You take any x, comma y, comma z in the domain. You express that x, comma y, comma z as a linear combination of given basis vector. Write it as ABC. After that, you have to find ABC in terms of x, y, z. Apply t on both sides. That is the idea. That means you will have t of x, comma y, comma z is equal to x plus y plus 2z, comma minus x plus 2y plus z minus x plus uh, 2y plus z, comma, y plus 3z. This is the linear map that takes 1 comma 0 comma 0 to 1 minus 1 0, 0 comma 1 comma 0 to 1 to 1, and 0 comma 0 comma 1 to 2 and 3. Can you verify this? You just put 1 comma 0 comma 0. What do you will have? X is 1 minus 1 0. Yes, we have got. If you put t of 0 comma 1 comma 0, you put y is equal to 1, 1 comma 2 comma 1. Yes, we have got 1 comma 2 comma 1. If you put z is equal to 1, you will have 2 comma 1 comma 3. Yes, we have got 2 comma 1 comma 3. This is the required linear map that takes 1 comma 0 comma 0, 0 comma 1 comma 0, 0 comma 0 comma 1 to this vectors, this matrix. Right? Yes. Now we need to find the matrix of T with respect to this basis, right? So what is our T of x comma y comma z? What is our T of x comma y comma z? T of x comma y comma z is here it is x plus y plus 2z, x plus y plus 2z, and then minus x plus 2y plus z, minus x plus 2y plus z, and then here we have y plus 3z, right? Y plus 3z. This is our required uh, linear map, right? Now what we need to do is we need to find the matrix of T with respect to the basis. We need to find the matrix of T with respect to the basis. What's our basis vector? 1 1 1, 1 1 1, and then 0 1 1, 0 1 1, and then we have 0 comma 0 comma 1, right? Yes, very easy, right? Already we know how to do. First we will find T of 1 comma 1 comma 1. What is T of 1 comma 1 comma 1? So 1 plus 1 plus 1 2 is 4, minus 1 3 minus 1 which is 2, and then 1 plus 3 is 4. Now what you have to do? You have to express 4 comma 2 comma 4 as a linear combination of basis vectors. So that means x1 times 1 comma 1 comma 1 plus x2 times 0 comma 1 comma 1 plus x3 times 0 comma 0 comma 1. If it is standard basis means you can easily find x1 x2 x3, but if it is not standard basis means something you need to work on it, right? We will work on it to find this x1 x2 x3. So you just have solve this equation. So x1 plus 0 x2 plus x3 is equal to 4, x1 plus x2 is equal to 4. By your luck, this is very easy to solve. x1 x1 plus x2 plus x3 is equal to 4, right? Just try to solve this. What you will have? If I multiply, if I add all the first component, you will have x1. If I add second component, you will have x1 plus x2. If I add third component, you will have x1 plus x2 plus x3. Now equate this to this. Now solve for x1, x2, x3. Implies x1 is 4. So x2 is minus 2. X1 is 4. And x3 is what? 4 minus 2 plus x3 is equal to 4. So x3 is 2. So what will be our first column? Our first column is 4 comma minus 2 comma 2. Yes or no? Because we have to write x1, x2, x3 in the first column. Yes. Now similarly we'll move on. We'll do the next thing. Now T of 0 comma 1 comma 1. Now what is T of 0 comma 1 comma 1? You have to substitute here. X is 0, y is 1, z is 1. So 1 plus 2 is 3, y is 1, z is 1. So again it is 3, y is 1, z is 1. So it is 4. Now you have to write this as a linear combination of some, you have to express as a linear combination of basis vector. Let us say x4 times, what's the basis vector? 1 comma 1 comma 1 plus x5 times 0 comma 1 comma 1 plus x6 times 0 comma 0 comma 1. Now if you try to solve this, what you will have? X1 is equal to 3, x4 is equal to 3, x4 plus x5 x4 plus x5 is equal to 3, x4 plus x5 plus x6 is equal to 4. This implies x5 is equal to 3 minus 3, which is 0. This implies x6 is equal to what? 4 minus x4, which is 1. Right? So we have got x3, x4, x5, x6, which it turns out to be 3, comma 0, comma 1. And similarly, what we'll do is we will find the matrix of T. We will find the image for T of 0, comma 0, comma 1. So T of 0, comma 0, comma 1. X is 0, y is 0, z is 1. So 2, and it is 1 here, and it is 3 here. Now you have to express this as a linear combination of basis vector, so which is 1 comma 1 comma 1 plus x8 times 0 comma 1 comma 1 plus x9 times 0 comma 0 comma 1. Now when you solve this, what you will have? You will have x7. x7 is equal to 2. x7 plus x8 is equal to 1. This implies x8 is equal to 1 minus x7, which is minus 1. And we have x7 plus x8 plus x9 is equal to 3. So what is x9? 3 minus x7, 3 minus x, 3 minus 2, 1, we will get plus 2, right? So the matrix of T with respect to the basis is given by the matrix of T with respect to the given basis. With respect to this basis is given by x1, x2, x3, x4, x5, x6, x7, x8, x9, right? All these are the unknowns which we found, right? So that means the matrix of T with respect to this basis is given by 4 minus 2, 4 minus 2 plus 2, 301, right? 301, 301, and then 2 minus 1, 2 minus 1 plus 2. So this is the matrix of T with respect to that basis. Is this clear? Can you move on to the next problem? Yes. Okay. So we have completed three problems. See how easy it is, right? Just how to express. See, with respect to the standard basis means very easy to express. Just output vector write as column. But if it's not standard basis means you have to solve, right? Okay. We'll move on to the fourth problem. So only two more problem pending. The time is 9:08. So last problem is very easy. I'm going to do this exercise for you. You can do anything. You can do that last problem. Last problem is only to find the rank of a matrix that you can do. That is a 10. That is 12th standard level problem. We'll do this problem now, right? So solution 20 marks, right? Very simple question. Verify Cayley-Hamilton theorem for A. Verify Cayley-Hamilton theorem for A. This carries 10 marks and this carries 10 marks, overall 20 marks. Show that A power n is equal to A power n minus 2 plus A square minus I for n greater than or equal to 3, where I is the ID matrix of order 3. So what Cayley-Hamilton theorem says? What Cayley-Hamilton theorem says? Cayley-Hamilton theorem. What Cayley-Hamilton theorem says is every square matrix satisfies its own characteristic equation, right? So every square matrix every square matrix satisfies its own characteristic equation, right? Its own characteristic equation. Every square matrix satisfies its own characteristic equation. So we will find the characteristic equation first. We will find characteristic polynomial or characteristic equation, right? So what is the characteristic polynomial for 3 by 3 matrix? I've already explained in the 2024 problem, right? It is lambda cube minus s1 lambda square plus s2 lambda minus s3. Now what is s1? S1 is nothing but trace of the given matrix What is trace sum of the diagonal element, which is 1 plus 0 plus 0, which is 1. Now what is S2? S2 is nothing but the for all diagonal element you find the minor. So for minor for 1 is corresponding column corresponding to 0 1 1 0 0 1 1 0, and the minor for this diagonal is corresponding column corresponding row 1 0 0 0, and the minor for this will be 1 0 1 0. So what this will be 0 minus 1 0 0. So minus 1 is the value for S2. And what is S3? S3 is nothing but determinant of A. So determinant of 1 0 0 1 0 1 0 1 0. So if you expand this, you will have 1 into minus 1. So minus 1 is the determinant for this matrix. So therefore, what is our characteristic? What is our characteristic polynomial? Characteristic polynomial is lambda cube minus s1 lambda square plus s2 lambda minus s3. This is our characteristic polynomial, right? I will substitute s1, s2, s3 values. Now, what Cayley-Hamilton theorem says is every square matrix satisfies its own characteristic equation. That is, if you substitute A in terms of lambda, so what we need to show is A cube minus A square minus A plus I is equal to 0. So I'm just converting in terms of matrix. You need to show A cube minus A square minus A plus I is equal to 0. We need to find the value of A cube minus A square minus A plus I. You show that it is equal to 0, then I can say that this matrix satisfies its own characteristic equation. That's what Cayley-Hamilton theorem says. Every square matrix satisfies its own characteristic equation, right? Okay. Um, so we'll do this now. These are just very elementary, right? You know how to find product for matrices, right? So first what we'll do is we will find A square. So what is A square? A into A. So 1 into 0, 1 0 1, and then 0 1 0. Multiply by 1 0 0, 1 0 1, 0 1 0. So if you multiply, what you will have? So this into this, so you will have 1 into 0 0 to 0, 1 into 0 0 into 1 0 into 1. So 1 into 1 0 into 1 0 into 0, 1 into 0 0 0, 1 into 1, 1 into 0 0 into 1 0, 0 1 1 1, 0 0 1 0 0 1, 0 0 1 1. See, you know how to find matrix multiplication, right? That's what I'm doing here. So A square turns out to be 1 0 0 1 1 0 and 1 0 1. Now similarly you find A cube, right? A cube is A square into A. So A square is 1 0 0 1 1 0 1 0 1. Now similarly you find A cube now. So what is A cube? What is A cube? So it is A square into A. So what is A square? 1 0 0 1 0 0, and then 1 1 0, and then 1 0 1. Multiply by A again. A is 100 101, then 0 1 0. So again you do multiplication. So 1 into 1 0 into 1 0 into 0, 1 into 0 0 0 0 0, 1 into 0 0 into 1 0 into 0, 1 into 1 into 1 will be 2, 1 into 0 1 into 0 0, 1 0 1 1 0 0, 1 1 0 1 0 0, 0 0 0 1 1 1 0 0 1. This is A cube, right? So A cube is given by 1 0 0, 2 0 1, and then 1 1 0. Now you know A cube, A square, everything you know. So you just substitute here and you show it is equal to 0, right? Now you find the value of A cube minus A square a cube minus a square minus a plus I minus a plus I. So what is a cube? A cube is 100, 201, 110 minus a square. So a square is 100, 110, 101 minus a. A is 100, 101, 010 plus ID matrix 100, 010, 001. Right? Now you try to add 1 minus 1 0 minus 1 plus 1 0. So you'll get this as 0. 0 minus 0 minus 0 minus 0. 0 minus 0 minus 0 minus 0. 2 minus 1 1. 1 minus 1 0. 1 plus 0 0. 0 minus 1 minus 1. Minus 1 plus 1. It is 0 0. 1 minus 1 0. Yes. So you can see that it is equal to 0. It is equal to 0 matrix. So therefore it satisfies Cayley-Hamilton theorem. Cayley-Hamilton theorem. See how easy it is, right? Cayley-Hamilton theorem. So first part is over. You got 10 marks. Now show that a power n is equal to a power n minus 2 plus a square minus I. Okay. So what we need to show is, now second part is we need to show a power n is same as a power n minus 2 plus a square minus I plus a square minus I for n greater than or equal to 3. So we'll prove by mathematical induction. So see, how we'll prove mathematical induction? We'll prove that it is true for n is equal to 1. Assume it is true for n is equal to k. Prove it is true for n is equal to k plus 1. See, what is mathematical induction? You'll be seeing many YouTube shots, right? They will keep a series of phones. They will push one phone, all the phones will fall simultaneously, one after other. That is mathematical induction. You say that first phone falls. You say first phone falls. That is, you show that it is true for n is equal to 1, right? You assume some kth phone falls. You assume some kth phone falls. You prove k plus 1 phone also falls. If I say this, then every phone will fall. Yes or no? If I prove this, then every phone will fall. I'm proving first phone falls. I'm assuming kth phone falls. I'm assuming kth phone is falling. You prove k plus 1th phone is also falling. If I prove these three, if I do these three, then entire phone will fall. Yes or no? Logically think. That is what I am doing here. If you have to prove it is true for all. That means you prove it is true for the first number. You prove it is true for n is equal to 3 because 3 is our first number. So first, what is step 1 is we will prove it is true. We will prove it is true for n is equal to 3. We will prove it is true for n is equal to 3, right? That means a cube is equal to a power 3 minus 2 plus a square minus I. So that means a cube is equal to a plus a square minus I, which is true by Cayley-Hamilton theorem. Because by Cayley-Hamilton theorem, what is a cube actually? A cube is a square plus a minus I. So a square plus a minus I is same as this. True by Cayley-Hamilton theorem. That is what we proved in the first case, right? So these two are equal by Cayley-Hamilton theorem. Because a cube is same as a square plus a minus I. So it is true for n is equal to 3. Right? Okay. Step 2. Assume it is true. Assume it is true for some n is equal to k. Let us say some kth phone false. I'm assuming some kth phone false. That means a power k will satisfy a power k minus 2 plus a square minus I. I'm assuming that kth phone false. What is step 3? Now we will prove it is true. We will prove it is true for n is equal to k plus 1. I'm assuming kth phone false. Now we'll prove k plus 1th phone false. If I prove this, then every phone will fall. That means it is true for all n. Okay. So we'll prove that. That is what I need to prove. You put n is equal to k plus 1. So a power k plus 1 is same as a power k plus 1. You put n is equal to k plus 1 plus a square minus I. This is what I need to prove. That is, I need to prove a power k plus 1 is same as a power k minus 1 plus a square minus I. This is what I need to prove. Right? We will prove this. So proof. This is true proof. This is true proof. It is, we need to prove it is true for n is equal to k plus 1. So we will start with the LHS a power k plus 1. So can I write a power k plus 1 as a power k into a? Now what is a power k? A power k is this. We already know because it is true for n is equal to k. That means I can write a power k as a power k minus 2 plus a square minus I will multiply a. So if I multiply a inside, what you will have? If I multiply a inside, what you will have? A power k minus 2 plus 1. K minus 2 plus 1 is a power k minus 1 plus a cube minus a. Right? You just multiply a inside. Now what is a cube minus a? Can I write a cube minus a as a square minus I? Let us call this as some star, right? So can I write a cube plus I? Can I write a cube plus I as a square plus a by Hamilton theorem? So this is a power k minus 1. Can I write a cube minus a as a square minus I by Hamilton theorem? So we have proved a power k plus 1 is equal to a power k minus 1 plus a square minus I. So hence the proof. So therefore a power n is equal to a power n minus 2 plus a square minus I. So we are proving mathematical induction. We have shown that it is true for n is equal to 3 directly by single stroke. I can say it is true by Cayley-Hamilton theorem because every square matrix satisfies its own characteristic equation. I'm assuming it is true for n is equal to k. I'm assuming this is true and I'm proving it is true for k plus 1. So this is what I need to prove. I'm starting with LHS a power k into k. A power k I can write like this because I'm assuming it is true already. I'm assuming it is true. Now multiply a inside a cube minus a I can write as a square minus I by Cayley-Hamilton theorem. So it is true, right? There is also some other part in this question, right? Show that a power n is equal to a power n minus 2 plus a square minus I for n greater than or equal to 3, where I is the ID matrix, I is the ID matrix of order 3. Hence find a power 40. We will find the value of a power 40 also. We will find the value of a power 40 also. Is it clear up to now? Is it clear up to now? Okay. We will find that value of a power 40 also. What we need to do is and also find the value of a power 40. It is not possible to multiply a 40 times a. So we will try to find some relation between. We need to find a power 40, right? Okay. So we know what is a cube. We know that we know what we know that a cube minus a square, a cube minus a square minus a plus I is equal to 0, right? We know the value of a cube minus a square minus a plus I is equal to 0, right? Okay. So that means what is a cube? A cube is a square plus a minus I, right? Now what is a power 4? I'm trying to find some relation, right? So what is a power 4? Multiply a throughout. A cube plus a square minus a. What is a cube? A cube is a square plus a minus I. Already we have plus a square minus a. These two will get cancelled. So we have 2a square minus I. right? A power 4 turns out to be 2a square minus I. Can we find a power 6 now? Can we find a power 6 now? So a power 4 into a square. So what is a power 4? It is 2a square minus I into a square. So we have 2a power 4 minus a square. So 2 times, what is a power 4 again? 2a square. What is a power 4? 2a square minus I minus a square. So 4a square minus a square. So 3a square, uh, 2a power 4 minus a square. A power 4 is 2a square minus I. So 3a square minus 2i, right? So a power 6 turns out to be 3a square minus 2i. Is it clear? A power 6 turns out to be 3a square minus 2i. Can we find a power 8 now? A power 8 is a power 6 into a square. What is a power 6? I'm just trying to find a pattern. So 3a square minus 2i into a square. So 3a power 4, 3a power 4 minus 2a square. So 3 times, what is a power 4? 2a square minus I minus 2a square. So this is 6a square minus 2a square is 4a square minus 3i. Yes or no? Minus 3i. A square, a power 4, 2a square, 6a square, 4a square minus 3i. Correct only, right? 4a square minus 3i, right? Okay. Actually, what is the relation between this? You can see if it is 8, it is 4, and then 1 less than 4. If it is 6, half of 6 is 3, and then 1 less than 3 is 2. If you have 4 here, half of 4 is 2, and 2 minus 1. So if you continue, if you keep on doing like this, what will be your a power 40? Half of 40 is 20. So 20a square minus 20 minus 1. So 19. This will be the value of a power 40. Yes or no? Is this clear? I'm saying comments. So 20a square minus 19i will be the value of a power 40 by symmetricity. Because half of 8 minus 1, half of 6 minus 1. So 20 times, what is a square? 20 times, what is a square? So a square is 100, 110, 100, 110, 100, 110, 101 minus 19 times I. 19, 0, 0, 0, 19, 0, 0, 0, 19, right? 100, not 1, 110, 101. Okay. So that means this will be 20 minus 19 is 1, 0, 0. This is 20. 20 minus 19 is 1, 0. This is 20. This is 0. 20 minus 19 is 1. So 100, 2010. Is it clear? 100, 2010, 2001 is the value of a power 40. Just try to establish some symmetricity. So that's it. We'll move on to the last problem. Last problem I'm not going to do. Right. This is nothing but to find the rank of a matrix. So I know if you are preparing for UPSC, for especially for max, these are just cakewalk for you, right? Just you have to find the rank of a matrix. So you reduce to row echelon form. After reducing to row echelon form, number of non-zero rows, right? Number of non-zero rows is your rank of a matrix. So reduce to row echelon form. I'm not going to do this, right? So reduce to row echelon form. You know how to reduce to row echelon form, right? R3 is transformed to. So what will be your step 1? R2 is transformed to R2 plus R1. R3 is transformed to R3 minus 2R1. R4 is transformed to R4 minus R1. After this step, these three will be 0. Again, you have to make these three as 0 first. After this, you make these two as 0. You make this as 0. Then you see number of non-zero rows, the reduced echelon form. You'll get the answer. So continue. The answer will be rank of A will be 3, I think. Yes. So rank of A is 3. So there will be 3 non-zero rows after converting to row echelon form, right? It is slightly time consuming, but if you are good in some addition, subtraction, multiplication, you can do this really fast, right? So that's it. So in this video, we have solved 5 problems of 2023 linear algebra. So again, every problem will be alike only, right? Concept is very important. Uh, in the next class or the